In this video, we're going to look at graphing exponential functions. You touched on this in Algebra 1, but you didn't do too much with it, so we're going to go a little deeper now. Here we have several characteristics of exponential functions that will make graphing much easier for me if I will learn them. First, the domain is going to be all real numbers, meaning no matter where I move on the x-axis, I can go up and find a y value. The range is going to be all positive real numbers. The x-axis here acts as a horizontal asymptote, which means I can never touch it. And if I can't touch it, I certainly cannot cross it. So, my range, therefore, is only all positive real numbers. Second, the graph of all functions in this form will pass through the point 0, 1. That reason is because of the exponential rule from Algebra 1 that anything to the 0 power is 1. Since x is my exponent, that would be raising it to the 0 power. So the y-intercept is going to be 1. Third, if b is greater than 1, then the graph will be like this blue one here, always increasing. Okay? And the greater the base, the quicker the increase. Number 4, though, if the b value, the base, is between 0 and 1, it is a proper fraction, 1/2, 1/3, etc. It will always be decreasing. And the smaller the value of b, the greater the decrease, the steeper the decrease. Okay, number 5. F of x equals b of x, that's my function, is 1 to 1 and therefore has an inverse function. And finally, the graph has a horizontal asymptote at y equals 0, that is the x-axis. And because it is an asymptote, I can't touch it, so there will be no x-intercept. So let's take a quick look at a graph and see just how easy it can be. First of all, because there's no transformations going on, I know it goes through the point over 0, up 1, right there somewhere. I can tell you also that it's going to be always increasing because this number is greater than 1. To find a second value, I'm simply going to plug in 1, which is a quick, easy 3. So over 1, up 3, right there. If you want to do another one, you can go over 2. That'd be over 2, up 9, which is off my graph. So I'm not going to do it. If it needed to be really accurate, I could also plug in a -1. 3 to the negative first power is 1/3. 3 to the ninth, or what, plug in a 2. 3 to the -2 would be 1/9, so it's going to be getting closer to that x-axis very quickly. But that's all that's required in order to graph an exponential function. I know that I mentioned transformations, but now I want you to see the full picture of what we can do with these graphs. First, a vertical translation, which is going to move the graph up or down. It occurs when you add or subtract a constant to the entirety of my function. Okay, that plus or minus c, and it works just exactly the same way it's worked on everything else we've graphed. Adding a c is going to move the graph up c units. Subtracting a c is going to move the graph downward c units. A horizontal translation will move it left and right. What will help you do that, because keep in mind left and right, that's the x-axis, is grouping the c with the x. And remember, it's considered grouped together, considered parentheses, so it always needs to be x minus. So it's going to kind of feel like it's going in reverse. But if you subtract c from x, making it in the exponent, you will shift the graph to the right C units. If you add C to the X, putting it in the exponent with X, you will move the graph to the left C units. The reflections, if you negate B to the X, then you will reflect that graph over the X-axis. If you leave B alone and negate the X, the exponent, you will reflect the graph over the Y-axis. As for vertical stretching and shrinking vertically, upward and downward, okay, that is a constant multiplied by the function. And if you multiply by a number greater than 1, you're going to stretch it. If you multiply by a number between 0 and 1, you're going to shrink it. And as for the horizontals, again, that involves left and right, so that puts the C with the X. And if you choose a number greater than 1, you will shrink it. If you choose a number between 0 and 1, you will stretch it. I know it's a lot to remember, but once you get the hang of it, it basically works the same no matter what we're graphing. So once you get the hang of it, it's going to carry over into everything.